Assalamualaikum warahmatullahi wabarakatuh. We are from group 3 and we are going to explain methods for handling deadlocks in operating system. I am Azzahra.
My name is Afifah Ivana Putri.
My name is Nauval Uzlah.
So in this essay, we're going to talk about our introduction, our basic theories, our problem analysis, and our conclusion and suggestion. A deadlock is a situation where a set of processes are blocked because each process is holding a resource and waiting for another resource acquired by some other process. A process in an operating system uses different resources in the following way. First, request a resource, the second is use the resource, and the third is release the resource. In a multiprocessing system, the allocation of resources can become a point of conflict. Such conflict can lead the system into a deadlock state. The scope of this topic is to explain deadlock system models, distinguish the condition that can lead into a deadlock, and methods for handling deadlocks.
Brief explanation of operating system. The operating system is the most important software that runs on a computer. It manages the computer's memory and processes, as well as all of its software and hardware. It is also allows you to communicate with the program without knowing how to speak the computer's language. Without an operating system, a computer is useless. An operating system is a program that manages a computer resources, especially the allocation of this resource among other programs. Management tasks includes scheduling resource used to avoid conflicts and interference between programs. Unlike most programs, which complete a task and terminate, an operating system runs indefinitely and terminates only when the computer is turned off. Introduction to a deadlock. In a multi-programming environment, there can be multiple processes using a finite number of resources. A process can request another resource while holding another resource. If the request resources are not currently available, the process can go into a panic state. This wait state may not end if a resource request by this process is pending in another waiting process. This situation is called deadlock, and none of the processes are ready to release resources and wait indefinitely for other waiting processes to free resources. A deadlock is a situation where a set of processes are blocked because each process is holding a resource and waiting for another resource acquired by some other processes. Consider an example when two trains are coming towards each other on the same track and there is only one track. None of the trains can move once they are in front of each other. A similar situation occurs in operating system when there are two or more processes that hold some resources and wait for resources held by others. For example, in the diagram, process 1 is holding resource 1 and waiting for resource 2, which is acquired by process 2, and process 2 is waiting for resource 1. In operating system, a deadlock refers to a specific state in which two or more processes are waiting for each other to release resources. More than one process may be waiting for a certain amount of resources.
Deadlock system models. A system model or structure consists of a fixed number of resources to be circulated among some opposing processes. In operating system, a deadlock refers to a specific state in which two or more processes are waiting for each other to release resources. More than one process may be waiting for a certain amount of resources. Under the standard of operation, any process may use a resource in only the below-mentioned sequence. The first one is request. When the request can be approved immediately, where the case may be when another process is utilizing the resources, then the requested job must remain waiting until it can obtain the resource. Second one is use. The read process can run on the resource, like where the resource is a printer, its job or process is to print on the printer. Third one is release. The process release the resource, like terminating or exiting any specific processes. Deadlock necessary conditions. The first one is mutual exclusion. There should be a resource that can only be held by one process at a time. Second one is hold and wait. A process can hold multiple resources and still request more resources from other processes which are holding them. The third one is no preemption. When a process is holding resource, once its request has been granted, that the resource cannot be taken away from the process until the process voluntarily releases it. The fourth one is circular wait. A process is waiting for the resource held by the second process, which is waiting for the resource held by the third process, and so on, till the last process is waiting for the resource held by the first process. Deadlock prevention. Deadlock can be prevented by preventing at least one of the four necessary conditions as I stated above. The first one is mutual exclusion, the second one is hold and wait, the third one is no preemption, the fourth one is circular wait. Deadlock detection and recovery. Deadlock detection. A. If source have a single instance. In this case, for deadlock detection, we can run an algorithm to check for cycles in the resource allocation graph. Presence of cycle in the graph is the sufficient condition for deadlock. The B is if the resource have multiple instances. Detection of the cycle is necessary but not sufficient condition for deadlock detection. In this case, the system may or may not be in deadlock depending on different situations. The second one is deadlock recovery. The first one is killing the process. Killing all the process involved in the deadlock, killing process one by one. After killing each process, check for deadlock again and keep repeating until the system recovers from a deadlock. The B is resource preemption. Resources are preempted from the process involved in the deadlock. Preempt resources are allocated to other processes so that there is a possibility of recovering the system from a deadlock. In this case, the system goes into starvation. In this approach, it is assumed that deadlock will never occur. This is also an application of the ostrich algorithm. This approach was initially used by Minix and Unix. This is used when the time intervals between occurrence of deadlocks are large and the data loss incurred each time is tolerable. Ignoring deadlocks can be safely done if deadlocks are formally proven to never occur. An example is an RTAC network framework.
So the conclusion and suggestion. Conclusion is a deadlock is a situation where a set of processes are blocked because each process is holding a resource and waiting for another resources acquired by some other process by some other processes. A deadlock can occur if the following four conditions or preconditions are met simultaneously: mutual exclusion, pending and waiting, no preemption, and circular wait. In operating system, a deadlock refers to a specific state in which two or more processes are waiting for each other to release resources. More than one process may be waiting for a certain amount of resources. Suggestion. In this regard, we suggest several things to note, such as the following: how to handle deadlock. First, deadlock prevention. The idea is to not let the system into a deadlock state. Second, deadlock detention and recovery. Let deadlock occur, then do prevention to handle it once occur. Third, ignore the problem. If a deadlock is very bad, then let it happen and reboot the system. This is the approach that both Windows and Unix take. So that's all from us. Thank you for the attention. Wassalamualaikum warahmatullahi wabarakatuh.